Good morning, my YouTube viewers. In this video, what we're going to talk about is inferential statistics. So inferential statistics is a branch of statistics that focuses on making predictions or inferences about a population based on a sample of data. Unlike descriptive statistics, which merely summarize data, inferential statistics go a step farther by using data to make generalizations, draw conclusions, and test hypotheses. So you've got the key concepts in inferential statistics. Inferential statistics involves several key concepts that form the foundation of its methods and applications, to include number one, population and sample. A population refers to the group of individuals or items of interest in a particular study and includes every member of the defined group. A sample is a smaller, manageable subset of the population selected for the purpose of conducting research. Sampling is used when it is impractical or impossible to collect data from the entire population. Then you've got parameter and statistic. A parameter is a numerical value that describes a characteristic of the population, such as the population mean or population variance. A statistic is a numerical value that describes the characteristic of the sample, such as the sample mean or the sample variance. Statistics are used to estimate population parameters. Then you've got the sampling distribution. Sampling distribution is the probability distribution of a given statistic based on a large number of samples drawn from the same population. It describes the variability of the statistic and forms the basis for making inferences about the population. You've got the confidence interval. A confidence interval is a range of values derived from the sample that is likely to contain the population parameter with a specified level of confidence, such as 95% confidence interval. It provides an estimate of the parameter with indication of the uncertainty associated with the estimate. Then you have hypothesis testing. Hypothesis testing is a method used to assess the evidence provided by the sample data to support or reject specific hypotheses about the population. It involves formulating a null hypothesis, that's HO, and an alternative hypothesis, that's either H1 or HA, and using a test statistic to determine whether to reject HO. So we've got methods of inferential statistics. Several methods are commonly used in inferential statistics to make inferences about the population, to include estimation. Estimation involves using sample data to estimate population parameters. Point estimation provides a single value estimate, the sample mean, while interval estimation provides a range of values, confidence interval, that is likely to contain the parameter. Then you have hypothesis testing. Hypothesis testing involves comparing the observed data to a full null hypothesis to determine whether there is enough evidence to reject the null hypothesis. Common tests include t-test, chi-square test, and ANOVA. You've got regression analysis. Regression analysis is used to determine the relationship between one or more independent variables and a dependent variable. It helps in predicting the dependent variable based on the values of the independent variables. You've got analysis of variance, which is ANOVA. ANOVA is used to compare the means of 3 or more groups to determine whether there are statistically significant differences between them. It is commonly used in experimental studies. So we've got the importance of inferential statistics. So inferential statistics allows researchers to make generalizations about a population based on sample data. This is crucial when studying the large populations where collecting data from every member is impractical. Inferential statistics provide scientific basis for making data-driven decisions. It helps in assessing the evidence, estimating uncertainties, and drawing reliable conclusions. Hypothesis testing is a cornerstone of scientific research. It enables researchers to test theories, validate findings, and advance knowledge in various fields. Inferential statistics is used to make predictions about future events or outcomes based on historical data. This is valuable in fields such as economics, medicine, and environmental sciences. So we're going to talk about data. Data is vital for several reasons. It's vital for informed decision-making, scientific research, identifying trends and patterns, and predictive analysis. Then we're going to talk about the different kinds of data. You've got data can be classified into several types based on their characteristics and the level of measurement. Here are the main types of data. So you've got nominal data that represents categories or names that do not have a specific order or ranking. Examples of nominal data include gender, eye color, and types of cuisine. You've got ordinal data represents categories with a meaningful order or ranking, but the difference between the ranks are not necessarily equal. Examples of ordinal data include education level, satisfaction ratings, and class ranks. You have interval data, which represents numerical values with equal intervals between them, but there is no true 0 point. Examples of interval data include temperature in Celsius or Fahrenheit, IQ scores, and calendar years. You've got racial data, which is similar to interval data, but it has a true 0 point, allowing for meaningful comparisons of racials. Examples of racial data include height, weight, age, income, distance. You have continuous data, which can take any value within a range and are often measured rather than counted. Examples of continuous data include height, weight, temperature, and time. You have discrete data. Discrete data consists of distinct, separate values that are often counted rather than measured. Examples of discrete data include the number of children in a family, number of cars in a parking lot, and number of students in a classroom. You have qualitative data, which describes qualities or characteristics and is often categorical. Examples of qualitative data are colors, names, and descriptions. You have quantitative data, which represents numerical qualities and can be measured or counted. Examples of quantitative data include age, salary, number of items sold, and distances. So I've made a little diagram to give you some insight into categories of data. So under the categories of data, you've got qualitative and quantitative. So under qualitative data, you've got nominal data and ordinal data. And under quantitative data, you've got discrete and continuous. So we ask the question, what is the difference between a population and a sample? In the realm of statistics, two fundamental concepts form the basis of data analysis, population and sample. Understanding the difference between these two terms is crucial for conducting accurate and meaningful statistical analysis. A population encompasses the entire group of individuals or items under study, while a sample is a subset of the population. So we've got a diagram of the population, which is the whole, and then a sample is just a part of that. So now what we're going to do is we're going to talk about sampling techniques. You've got different sampling techniques. You've got probability sampling and non-probability sampling. And the sampling techniques that we're going to discuss in this course are going to be probability sampling of random, stratified, and systematic. But I just wanted you to know about non-probability sampling as well, which is snowball, quota, judgment, and convenience. So what we're going to do is we're going to stop this part of the course, and then we're going to go into Python, and we're going to cover sampling techniques in Python so you can understand sampling techniques in Python. So that concludes the textual part of the course. And now we're going to go to the practicalities of the course. It's coding. So thank you for watching this video.